So we are kind of smack in the middle of goal number 4. That was our first goal we began after the midterm, in which we're going to extend the properties of arithmetic that we know to study the algebra of polynomials. So our first topic, topic 6, was where we used exponent properties to simplify monomials and combinations of monomials. We just got done with topic 7, where we simplified sums, differences, and products of polynomials using a variety of approaches. And so now, as I mentioned, we're ready to spend some time undoing what we did in the first goal of the course. So we're going to undo the processes of multiplication in particular by learning some techniques for factoring. And as I mentioned in our last class, the visual approach, the model that I'm going to fall back on most, that I like to recommend for thinking about factoring, is the lattice model. So what I'd like for us to do today is to get some practice using the lattice model, not to work from the outside in, which is multiplication, but to work from the inside out, which is where factoring comes from. We can find all the factoring material that is in both this topic, number 8, and also the topic which follows, which is topic B, one of the additional topics for our course. So it's not in the core. The factoring topic is, but the advanced factoring topic is not. All that material can be found in a combination of chapter 7 in our text, as well as the first section of chapter 8. So as you're reading through your reading assignments through Blackboard, those will be the sections that you end up looking at. So today we're going to put most of our focus on this first technique of factoring out the common factor. And if we have some time, we'll also move down to factoring trinomials with a leading coefficient of 1. But actually, yeah, let's just start there, and then maybe we'll get a little bit of a taste of this this topic in chapter 8, solving quadratic equations by factoring. I kind of like to use that as a way to motivate why we would even care about factoring. So why would we even care about factoring? One of the whole purposes of us studying anything in algebra is that we want to know how to solve more different types of equations. And so before we get to the how of factoring, I want to use solving equations as a way to motivate the why. So in this example, we have an equation, x to the second power minus 5x minus 14 is equal to 0. And our job is that we want to solve this equation. In other words, figure out what x's are going to make the expression on the left-hand side here equal to 0. So let's imagine for a moment that we know how to factor the expression that's on the left-hand side. So let's for the moment imagine that we know how to factor x squared minus 5x minus 14. So it turns out that for our purposes, what that process of factoring is going to look like is, again, it's going to be a chance for us to work one of these lattice diagrams from the inside out. So x squared minus 5x minus 14 is the thing that I want to get when I multiply something by something. And setting up a lattice that's 2 by 2, like this, is maybe one way to begin thinking about how we might factor this expression. And then I'm just going to quickly go through, without explaining my steps right now, because we'll get to that, go through the steps that I would take to factor this polynomial using a lattice. I look at the x squared and say, well, what can I multiply together to give me an x squared? Well, the answer to that, whenever we're factoring something, is usually just x times x. That gives me x squared. And then I would ask, what can I multiply by what to give me negative 14? And there I have several different choices. Negative 14 and positive 1, positive 14 and negative 1, negative 7 and positive 2, negative 2 and positive 7, or maybe some scary, nasty fractions and irrational numbers and other stuff that I could multiply together to give me negative 14. But suppose that I get super duper lucky and I happen to guess that maybe I can try negative 7 and positive 2. In other words, here I am working this lattice from the inside out. But then I have these two blank squares. So now that I've made my guess, whoops, this is positive 2. Now that I've made my guess, I'm going to finish filling out this multiplication lattice and see if my guess was actually correct. And when I fill out the rest of this lattice, I get in this square negative 7x. I get in this square positive 2x. And if I were then to simplify the sum of everything which is in here, I will get x squared negative 7 plus 2 is going to give me negative 5, so x squared minus 5x minus 14 So indeed, this is a valid factorization of this expression. That was a very quick example. We'll go more into depth into how I did that in a little while. But supposing that I do that, then I can replace this expression on the left-hand side with the product of x minus 7 and x plus 2. After all, that's what I see now on the first row in the first column of my lattice that I've worked to the outside. So if this multiplication lattice is correct, then it means that x minus 7 times x plus 2 is the same thing as that expression that we started with. But so what? Why do we care? Why does that actually help us to solve this equation? Well, because I've replaced the arithmetic on the left-hand side of this equation, which used to be addition and subtraction focused. I've now replaced it by something which is multiplication focused. I've seen this expression as the product of one thing times another thing. And not only that, the other side of this equation is 0. So I've reframed the problem in a way that lets me ask, how do I multiply together two numbers and get the answer to be 0? What does that tell me? If I'm multiplying two numbers together and the result is 0, what does that tell me about the original numbers? It's an example of a pair of numbers which, when we multiply them, they cancel out to 0. Give me a multiplication problem whose answer is 0. This is Jeopardy again. You can come up with a whole giant list of multiplication problems whose answer is 0. What do all of the problems have in common? One of their factors is 0. Exactly. The only way in the real number system to get a product of 0 is for one of the factors to have been 0. Right? The only way to get 0, in other words, is to multiply by 0. So, what that tells me about this equation is that the only way that this left-hand side is going to be 0 is if one of the things that we're multiplying is 0. That's a key property for us. It's a principle called the zero factor principle, or the zero product property. It goes by a lot of different names. I'm going to call it for us the zero product property. The zero product property says that the only way to get one thing times another thing to equal 0 in the real number system is to have one of them itself to have been 0. Instrumentally, I like to think of this as a splitting of one difficult equation into two much simpler equations. And I'm going to put a little conjunction in here. Just put an or. Right? One or the other of those two quantities, x minus 7 or x plus 2, has to be 0 in order that we get 0 when we multiply them together. Right? And now each of these two equations that we just got is much simpler than the one that we started with. How do I solve x minus 7 equals 0? Yeah, just add 7 to both sides. We find out that x equals positive 7. X plus 2 equals 0. Subtract 2 from both sides to get x equals negative 2. And now that we have identified two values of x that make this equation true, we've solved this equation. We found the solution of this equation. And so this is the typical arc of how we're going to begin the process of solving polynomial equations. The arc is going to be factor and split. Right? And this works exactly when the other side of the equation is 0. So that might be even before the factoring step. Get a 0 on one side. So 0 it, factor it, split it, and then solve it. So this is why factoring is a powerful tool, is it gives us the first tool that we have this semester to solve an equation that has a polynomial in it. Right? So far, all the equations that we've solved have had degree 1, so everything was just linear. We could use the first two rows of the arithmetic layer cake, addition, subtraction, multiplication, division, could do everything for us. Right? They could solve any equation for us. But now that we're playing in a new weight class here, solving polynomial equations requires us to develop a new set of tools, and factoring is our first and most significant tool for that.